Hello students, welcome to lecture of kinematics and theory of machine. We are going to start new chapter which is a gear train, and topic we will cover in this lecture is the introduction to gear train, and we will study simple gear train in detail. Okay, let's start. Okay, let's start with the introduction of a gear train. Two or more gear made to mesh with each other to transmit the power from the one shaft to the another. Such a combination is known as a gear train. This combination is known as a gear train. So two or more gear made to mesh with each other. So check this. When two or more gear are connected to transmit the power from the one shaft to the another shaft, then it is known as a gear train. You can see in this figure, this is the driver shaft. Okay, and there are two gear, intermediate gear are connected in between them, and this gear number 4 is a driven or follower. So we want to transmit power from this gear to this shaft number 1 to this shaft number 4. So we can use the two or more gear, then it is known as a gear train. Okay, so there are 4 types of gear trains. First is a simple gear train, compound gear train, reverted gear train, and epicyclic gear. So these 4 types of gear train we will study in detail in this chapter. So let's start with a simple gear train. Okay, so first of all, what is a simple gear train? When there is only one gear on a shaft, each shaft is known as a simple gear train. Means one gear on a one shaft. Okay, you can see here there is a shaft. You can see shaft number 1, shaft number 2, and same as on shaft number 1, gear number 1 is mounted and it is called as a driver, and second is a driven. Okay, when gear number 1 is rotating in a clockwise direction, motion will be transmitted to gear number 2 and direction will be in a anti-clockwise direction. Okay, so that's how this is the simple gear train, very basic gear train, one gear on each shaft. Okay, you can see here the motion. If there is a distance between two shafts is larger, you can see here the gear number 1 and gear number A and gear number C, there is a distance, more distance is there, so the idle gear can be added between them. Okay, so it is known as a simple gear train. You can see here there is only one gear on each shaft, so every shaft can has only one gear, so it is known as a simple gear. Basic funda behind the simple gear is, you can see here the small pinion which is rotating, and due to that this wheel is rotating in opposite direction. So remember that whenever external gear two gear meshing, if they are external gearing, then direction will be changed, and if there is an internal gearing, the direction will be same. You know that if the one gear is that with this center and second gear is mounted inside that with this center, if gear outer gear is rotating in this direction, then direction of internal gear will be same. Okay, remember that in internal gearing direction is the same, and in external gearing direction will be opposite. Okay, this funda will be used in example also. And you can see here, the larger the gear, the RPM will be decreased. If I am saying that there is a 200 RPM is there, so what will be RPM of this? Due to, you can see the size of this gear is increased, so RPM will be decreased. I am giving this value approximately, but you can see that the larger the wheel, RPM will be decreased. So number of teeth and RPM is inversely proportional. larger the number of teeth is high, then RPM will be decreased. Okay, let's understand the speed ratio. What is the speed ratio? So you already know that. You can see here, the smaller the gear size, less number of teeth will be there, and RPM is always high with respect to connected gear. If a smaller gear is connected to larger gear, you can check here the RPM is decreased, means number of teeth is higher but RPM is less. So I can say that RPM is proportional to 1 upon number of teeth. So you can check that higher the number of teeth, T is high in this case, but RPM is less. And you can see here the less number of teeth, but RPM is high. So first of all, we what is the speed ratio? Speed ratio is just the ratio of the speed of the driver to the speed of the driven. Okay, you can check this relation. If I know the number of teeth of both gear, this is the ratio which will helpful to me for the finding the speed of the driven. How? Check this. This is the gear number 1 and this is the gear number 2. I have connected the motor here. Driver means motor is connected, and I know the RPM of the motor. So gear number 1's RPM I know that, and teeth, both gears are teeth I know. So you can find the what will be the RPM from this gear ratio. So you can check the RPM of the driven from this relation. What if the more number of teeth are there, gears are there, between driver and driven, there is, if I have connected one gear between them, what will be the relation between RPM of driver and RPM of driven? Speed ratio for this particular case, what will be the N1 upon N3. I want to speed ratio with this for this system. So let's find the speed ratio for this system. So first of all, gear 1 and 2, you know that relation between two gear. For gear 2, who is the driver? For gear 2, 1 is a driver because 2 is rotating due to the gear number 1. So relation between these two gear will be this: N1 upon N2, driver upon driven, is equal to teeth of driven upon teeth of driver. Okay, clear up to this point? And then you can see here, gear number 2 is rotating gear number 3. Ultimate driver is a gear number 1, but for right now you can check this gear number 3 is a rotating due to this gear number 2. So for gear number 3, let's understand the motion transmission between 2 and 3. What will the relation for the 2 and 3? You can check here, the gear number 2 is a driver for gear number 3. So N2 upon N3 is equal to teeth of the gear number 3, means driven upon driver. So you can check for 1 and 2, and after that between 2 and 3, same relation, and say this is the equation number 1 and this is the equation number 2. Multiplying this both equation, and you can find this, and among that you can cancel out N2 and you can cancel out T2. What will happen? N1 upon N3, it is the RPM of 1 divided by RPM of the driven, which is known as a speed ratio. So you can find the speed ratio in that way. So ultimately equation you can check here, N1 upon N3 means RPM of driver upon RPM of driven is equal to number of teeth of driven divided by number of teeth of the driver. Okay, so I can say that whatever the number of gear are there in a simple gear train, ultimately speed ratio is speed of the driver upon speed of driven is equal to number of teeth of the driven divided by number of teeth of driver. So you can check this. There is no relation or interference by this gear number 2. Means there is a no T2 is there. Okay, so what you have learned means transmitting for motion from gear number 1 to gear number 3, there is a no effect, means there is a no effect of gear number 2. So first of all, check this equation and we are going to see how this helpful gear number 2 here. Okay, so now I am giving another other example. If there is a 4 gears, what will be the speed ratio for this system? So I can write this N1 driver, this is the driver, and this is the driven. So N4 is equal to number of teeth of driven, means T4 divided by number of teeth of driver. So this is the basic equation we will use every time. But there are intermediate gear we have assembled in between 1 and 4. So these intermediate gears do not affect the speed ratio. Okay, so why we using these gears? What is requirement of using this type of gear between the driver and driven? So check this. So to connect the gears when the large center distance is there, okay, I can say if the center of first gear is here, this is the shaft, and driven shaft is here. So I need to transmit the RPM for some 50 to 75, increase the RPM. So according to this RPMs, the size of gear will be fixed, but I want to fill this space between them, so it can be done by these idle gears. Okay, another use of this idle gear is to obtain the desired direction of the motion. You have checked or not? I am going to show you what is happened. Okay, I am showing you why how this direction can be changed by using the idle gears. You can check the direction of gear number 1 is a clockwise, and outer gear, means driven gear, is a anti-clockwise. So if I want the direction of this 4th gear in a clockwise, what can I do? I can eliminate all 2 these gears and using one single gear in place of both. So this direction can be obtained. Okay, you can see here. So first of all, check this. If the number of idle gear is odd, then the direction of a driver and driven is the same. If the number of idle gear is even, then the direction is a change, and it is in opposite direction. Okay. Okay, you have seen the simple gear trend, how it transmits the motion. There is a gear ratio which is known as a N1 upon N4 for this particular system. N1 upon N4 is equal to T4 upon T1. But there are some limitations are there. Like I'm giving you an example. If I want to transmit the motion and I want to reduce the RPM, like there is a one gear whose RPM is 500, and if I want to reduce this RPM to directly 50, 500 to 50, there will be large reduction is required. So this gear will be larger, because you know that what is the gear ratio? Gear ratio is N1 upon N4 is equal to T4 upon T1. So for that, larger the reduction you required, bigger the gear will be. Okay, so that's why in this simple gear trend there is a limitation of speed reduction. You can't reduce the RPM by large number in large ratio.